Hi everybody. Today we are going to review area of the sector and arc length. So let's talk about area of a circle first. What do we need to know about area of a circle? We need to know that this is the radius, and my pen is not on. This is the radius. The radius goes from the center to the end point of the circle. The area of the circle is pi times the radius squared. Let's talk about the area of a sector. What's a sector? It's a shaded section of the circle. It's made with two radii, and this section right here would be called the shaded sector. And it should remind you of like a piece of pizza. The circumference of a circle is all the way around the circle. Kind of like the perimeter if you think about it. The distance around the circle, our circumference formula is pi times the diameter, but we do know that two radii make up a diameter, so we could also say 2 pi r. What is arc length? That's like the crust of the pizza. That's this section from here to here. Okay, all the way around, right, is the circumference, and just a little piece of it we call the arc length. There are two ways to measure an angle, right? I always say check to make sure that your calculator is in degree mode. And if it's not in degree mode, it's in radian mode. We know that 360 degrees is 1 time around the circle. I'm just going to make a little symbol for a circle. And 1 time around the circle, if we were measuring in radians, I should put an S there, in radians will be 2 pi. So you can see that 360 degrees is equal to 2 pi radians. The math that I'm going to show you is not new, just the concept is. So if we are dealing with the area of a sector, you see that it's this little piece that's shaded in compared to the area of the entire circle. So technically it is a little to big problem, and you're all familiar with little to big. So we're going to take the measure of the angle, and whether we're dealing with radians or degrees, that goes in the denominator, equals the area of the sector, just the small, versus the area of the entire circle. Okay. Keep in mind when it says the area of the entire circle, that's when we will remember that area of a circle is equal to pi times the radius squared. Let's take a look at number 2. And you see this is the whoa, what happened there? This is so sensitive. And this is the shaded area. So all we're going to set up is a little to big problem. And fill in the pieces. So the angle is given as 270 degrees over the entire thing. The big piece would be 360 degrees. And it says we're looking for the shaded section, so we don't know that, over the area of the entire circle, which is pi times the radius squared. I want you to pause your video and get your answer for x. Notice that it said to the nearest hundredth. That's 2 places past the decimal point. Now all you had to do was cross multiply, and hopefully this was the answer that you got. Notice I gave it centimeters squared because we were finding the area. Right? We were finding the area of this section right in here. When we talk about arc length, remember that's like the crust of the pizza. The beginning part is the same, the angle over 360, or 2 pi. It's still a little too big. The little piece to the entire distance around the circle is equal to the arc, or you really should say arc length, over the total circumference of the circle. And remember that circumference is equal to 2 pi r. Let's take a look at number 4. No picture, but that's okay. If a circle has a circumference of 24, what is the length of the arc given by the angle pi over 3 located at the center of the circle? I don't even need to draw a picture. I'm just going to do my little to big. Okay. What do I know? Do I know the measure of the angle? I do. They said it was pi over 3. So since it's pi, I'm not going to use degrees down here. I'm just going to use radians, 2 pi. If the angle's given in terms of pi, use radians. If it's given in terms of degrees, use degrees. And it's asking for what is the arc length. That's my unknown over the circumference of the circle. Well, this was lucky. They told us the circumference of the circle was 24, so I didn't need to use any formula. Now, when you see pi over 3, keep in mind that there's really a 1 there. So this might be easier for you to see as 1/3 pi. We're going to do the same thing. We're going to cross multiply, so we get 2 pi x is equal to 1/3 pi times 24. Now, because there's a pi on both sides, we can just reduce those. And now we have 2x is equal to 1/3 times 24 is 8, divide by 2, and x is equal to 4. Let's take a look at this question. In the diagram below of circle O, the area of the shaded sector AOC is 12 pi squared, and the length of OA is 6 inches. Determine and state the measure of angle AOC. So because we have two formulas we're dealing with, arc length and area of a sector, if they talk about the shaded sector, then we know we're using that formula. If they mentioned arc length, well, then that would be the other formula. We set these up the same way, little to big, except this time we were given a little bit of different information. They said, determine and state the measure of angle AOC. So we don't know the measure of the angle. Since they gave us the shaded sector in terms of pi, I could either use 2 pi or I can use 360. One answer will give me the measure of the angle in radians, and if I use 360, it would give me the measure of the angle in degrees. Now, do I know the area of the shaded sector? I do. It's 12 pi. And remember, it's over the area of the circle. Well, the area of the circle is 2 pi r squared, so pi times, and the radius is 6 squared. Now we're going to cross multiply. I like to keep it in terms of pi as long as I can because I don't want to deal with any decimals. And since they gave it to me, the area in 12 pi squared, I'm going to give my answer of the angle in terms of pi. So let's cross multiply. Let's see what we get. We get 36 pi x, and on the right side, 2 times 12 is 24 times pi times pi. Now, very quickly, my pi's can reduce. I have 36x is equal to 24 pi. Remember, we're solving for x. Divide by 36. And we get x when I reduce this answer, because if it was a multiple choice question, it would be reduced, is 2/3 pi, and that is the measure of angle AOC. Could I also do this problem in degrees? I could, and I would get 120 degrees. this is the last question I'm going to do with you. We're given triangle FGH is inscribed, meaning it's inside circle O. The length of radius OH is 6. That's marked. We're also given that FH is congruent. Let me just mark this. Where's my FH is congruent to OG. What is the area of the sector? So I know which formula I'm going to be using. Formed by angle FOH. So, you know, I like to put a little dot in the angle that I'm looking for, leave answer in terms of pi. So you notice OG is a radius. Things we want to remember is that all radii in the same circle are congruent. And let's see if we can erase that. I'm not really sure I'm doing that right. All radii in the same circle are congruent. So let's look quickly. So if OG is a radius, OF is a radius. So they're congruent. Wait, now these are also congruent. Oh, OH is also a radius. Look at this triangle. What type of triangle is FOH? Did you say equilateral? If you did, you are correct. So therefore, triangle FOH is equilateral. And what do we know about all angles in equilateral triangle? Did you answer 60 degrees? So now we know that angle FOH is equal to 60 degrees. We didn't answer the question yet. We found the angle, but this says what is the area of the shaded sector. So keep in mind that we want this right here, the shaded sector. But at least now we have enough information to find that. So let's set up our proportion. Keep in mind, it's still little to big. Do I know the angle? I do. It's 60 degrees out of 360 degrees. Do I know the area of the shaded sector? No, that's what they're asking for. Over the area of the circle, which is pi times the radius squared. So I want you to pause and solve for the angle in terms of pi. Then check your answer. How did you do? Did you get 6 pi? I hope you did. All right. Have a great day.